So let's talk about variables. And variables have one purpose, not just one purpose, but they're very useful. They store value in memory. One of the benefits of computers is that they have a lot of memory. In fact, you guys are lucky because you have computers that start at 8 gigabytes of memory and phones that start at like 2 to 4 gigabytes of memory. My first computer, I think, had 128 meg, which is much, much smaller. You guys don't know about the days of floppy disks where you wanted to run a game and you had to flip through 15 different floppy disks while playing a game. Drove me crazy. So the purpose of a variable is to store a value in memory. And that's so we can access it later. No, number is not considered a data type. Integer and floats are the data types, but they're types of numbers. So number itself is not a data type. So storing data. If we want to write something that stores data, in Python, we would do this. That equals sign is actually not called an equals sign here. It's actually called an assignment operator. And it's actually the lowest priority. It actually is an operator. It's the lowest priority. Everything on the right happens first. So it goes right to left, not left to right. And that 3, in this case, is a value, but it's actually an expression. In this case, it just happens to be a value, so we don't have to do anything with it. And then when you have that n equals 3, somewhere in memory, you have some block of memory that holds that value and is associated with that letter n. And so we can do stuff right with it. So now we have that 3 stored somewhere in memory. And if we have another line, n equals n plus 1. Now, you cannot have the same name for a variable. So what this is really going to do is it's going to do something with the existing variable. And so first, it's going to do a lookup. It says n right here. What's the value of n? Well, in memory, the value of n is 3. So it returns a 3. We add 1 to it. Obviously, that answer is 4. That 4 is then stored in memory, which means this now turns into 4. So now the memory location has been updated, has been replaced. We've done what's called a variable update. And if we were to print out 1, 2, 3, if we were to print out n, it's going to print out the value 4 for us. And so if we do this in idle, and I'm rerunning it because it's getting a little annoying that I'm stuck at the bottom. So n equals 3. If we just type n, we'll print out n. So that means n has a value of 3 somewhere in memory. N equals n plus 1. So it's going to retrieve the 3, add the 1, add that value back to n. And so now when we print out n, we get the value of 4. We could keep doing this. N equals n times 100. What's the current value of n? Well, it's 4. 4 times 100 is going to give me 400. It's going to be assigned back to n. So when I print n, I should have 400 in. So we're storing this integer, this number, inside of a memory location, but we're using that name n to designate, like, how do I get to that thing? It's like, where in memory are you? Well, follow the n to get there. And so I believe capital letters are different. So N and N, yeah, capital letters are different. I haven't met a language yet that doesn't have differences, but sometimes you never know. Usually they're what we call case sensitive, meaning in order to use it. And that's actually a common problem in Java is if you misspell something or you capitalize something incorrectly, you're not using the same value because you can't find it. It's like giving your best, or not your best friends, like meeting someone at UCSD, giving them your dorm number and getting the numbers backwards. I'm over at 123, but you wrote down 321. They showed up in the wrong place because they didn't have the right number. So it does matter. Let's do a quick example of more than one variable. X equals 1, Y equals 2, Z equals X plus Y, Z equals X minus Y, Z equals X times Y. So that's a lot of stuff. And then I want to know, when I print out Z, what's my value going to be? What's going to be the value of Z? And if you go through this in code, obviously in the console, we put one line at a time, but if you're actually writing this in one file, it runs downward. And so we have to do this line by line. So let's make a section for memory. We're going to have some memory location designated to X on the first line, and we're going to put 1 in there. On the second line, we get a memory location designated for Y, and we put 2 in there. On the third line, we get a memory location designated for Z, and we'll get the value of X, which is 1. Get the value of Y, which is 2. Add them together, which is 3. Assign that to the memory location Z. Now we have 3 in there. So on the fourth line, we have 1, which is X, minus 2, which is Y. We get negative 1. So this is actually going to change to negative 1. On the next line, we take X, which is 1, 2, which is Y, 2 plus 1 is, 2 times 1 is 2. And now we store 2 inside of Z. So Z actually has a value of 2. And so when we print this, we're going to get the number 2. And we run that in idle. X equals 1, Y equals 2, Z equals X plus Y. We should get 3. We do. X minus Y, print Z, we get minus 1. X times Y, print Z, and we get 2. And so why are variables useful? For many, many, many reasons. But one area where they're useful is for letting us do things like calculations, formulas, storing things. Let's do the volume of a cylinder. The volume of a cylinder, I'm going to use letters. Pi, r squared height. We have some radius. We have some height. And if you think about, well, what variables do I need to calculate this? I need a radius, or we can use r. Normally, I would say don't use a one-letter variable name, but for a formula that uses that variable name, it's probably fine. So now we have radius or r, height or h. We have variable names we can use, and variable names should describe the value that it holds. In this case, r and h are fine because we can reference the formula. And then we need to store the volume somewhere. And I'm going to use capital V for the volume, so we can use uppers or lowers. And if you think about like what the formula is, right? If I want to do this, And by the way, you could also do multiple words, but if you do multiple words, we do what's called camel case, where you start with a lower and then you do an upper as the next word. So if I have an example of radius equals 3, height equals 7, and then I want to do the volume, the formula is pi. Now we can talk about whether you just want to put pi down there or use a constant from the math library, but we haven't introduced the math library. We're going to do that in a future lecture. So let's not worry about it for now. So pi, and then there's two ways you can do this. You can multiply r and r, because that's r squared, r times r. Or you can multiply this by r raised to the 2 power. So you can do either way. And just so you know which part I'm doing here, you can do either one of those. Either work. And so if we drop this in idle, we have r equals 3, h equals 7, v equals 3.14 times r to the 2 power times h. And I print out v. I get some really large number that is probably accurate, but I would probably need to check on a calculator. And notice this rounding thing going on. I have no idea where that O2 came from. That's just part of the rounding of floating point numbers.